Well, we are back together for a discussion on Section 2.2, Graphs of Equations. And we'll start out with a couple things that I hammer home when I teach beginning and intermediate algebra. If someone is looking for the x-intercept of a function, all you need to do is set y equal to 0, and then you can solve for x. So if you want an x-intercept, set y equal to 0. And if we're looking for the y-intercept, we're going to set x equal 0. Now, linear functions are lines. I'm sure we remember that. And positive slope, ride them in a car from left to right. We're going uphill. Our little guy is happy. He's going uphill from left to right. This is a positive slope. And if we're going downhill from left to right, we have a negative slope. Okay, so quadratic functions look like, their graphs look like a U. We call it a parabola. And we might remember that quadratic equations take the form y equal f of x equal ax squared plus bx plus c. And if the graph opens up, we know that a is greater than 0. If we have a parabola that opens downward, quadratic that opens downward, we know that a is less than 0. That should be a review, but we will look at that in greater detail in future lessons. Cubic equations, we don't need to say a whole lot right at the moment. Y equal ax cubed plus bx squared plus cx plus d. And I will say this: if we have a cubic equation, a is greater than 0, the right side will point up and the left will point down. Whoops, excuse me. Don't want that in there. If a is greater than 0, right will point up, left will point down. If we have a cubic equation and a happens to be less than 0, then the left will point up and the right will point down. I think of cubic equations as an S, and we'll do a couple activities in class when we are together to kind of help us remember what these look like. Square root functions, y equal f of x equal the square root of x. They kind of look like, I don't know, maybe a surfer dude with one arm out, if you will. We know that when we deal with square root functions, we have to think about restricting our domain. For instance, on this, the domain is all non-negative real numbers. So when we talk about graphs and graphs of different types of equations, one of the things that we like to look at is symmetry associated with them. And we're going to get ready to test graphs for symmetry. Here's a graph that is symmetric with respect to the y-axis. One thing you'll notice, if it's symmetric with respect to the y-axis, the y-coordinates are going to be the same, and the x's should be mirrors of each other. Notice x and negative x here. So our test for symmetry, we substitute x for negative x. I like to think of it like this: if I've got a point xy on the graph, then another point on the graph is the point negative x, y. Now, a graph that's symmetric with respect to the x-axis would not be the graph of a function, of course, but you'll notice that our x-coordinates are the same here, and our y-coordinates are opposites of each other. So we've got xy and x negative y if we're going to have symmetry with respect to the x-axis, and so substitution of negative y for y leads us to that equation. And then there are times when we have symmetry with respect to the origin. You'll notice here that we have to replace x and y with their opposites. So we substitute negative x for x and negative y for y at the same time. And if we get an equivalent equation, then we know we have symmetry. So with the origin, here's my point xy, here's my point negative x, negative y, and we're going to see where we have our symmetry. So we look here at example 1 in our discussion, and we're going to graph the equation. We're going to label the x and the y intercepts and then figure out whether we have symmetry or not. Just as a reminder, we have an x-intercept when y equals 0, so let's just do that. 0 equals 1/2 x squared. And we know if we clear the fraction, 0 equals x squared and 0 equals x. Now, that's my x-intercept is at 0, 0. Well, we'll note that would also be the y-intercept also. So we've got that point right there. Now we're going to check out symmetry. We can graph this if we want. We know if x is 1, y is 1/2. We know if x is negative 1, y is also going to be 1/2. So we can plot those 2 points. If we check out x equal 2, 2 squared is 4. Cut that in half, that's 2. And if x equals negative 2, negative 2 squared is 4, cut that in half. So 2, 2, and negative 2, 2. Okay, and we can test for symmetry here. Something that, well, let me make note of. Let's back up here just a moment. You're noticing this phrase with respect to. With respect to. Abbreviation or a notation that I would like to share with you. You're going to see this in class from time to time. WRT means with respect to. And so we'll use that, and I think you guys will enjoy using that in your work as well. We're going to go and test for our symmetry with respect to, well, let's see, what's it look like it's symmetric with respect to? Looks like it's symmetric with respect to the y-axis, doesn't it? So let's test that out first here. Symmetric with respect to the y-axis. And so how do we test that? Well, we replace x with negative x, and let's see what we get here. Y equals 1/2 times negative x squared. Well, this is 1/2 x squared, and we get an equivalent equation. So yes, it is symmetric with respect to the y-axis. If we check with respect to the x-axis, and just looking at it, you know, that would be a reflection down here. We certainly don't expect that to be the case. Let's just check it out. Negative y, well, first of all, we'll remind ourselves we replace y with negative y. And so negative y equals 1/2 x squared, negative 2y equals x squared. And, you know, there's no way, I guess really what we want to say here, we're solving for the new y, and I apologize, solving for the new y here, and so we divide both sides by negative 1, and we'd get y equal negative 1/2 x squared, which is not equal to x squared over 2, so it is not symmetric with respect to the x-axis. And then of course, with respect to the origin, we can see quickly that it's not going to be, there's negative y equal 1/2 times negative x squared. Well, negative y equals 1/2 x squared. So y equals negative 1/2 x squared, and it is not symmetric with respect to the origin. So problem 6 from your set, example 1 here in our notes. Moving along, we see problem 16 from the problem set here. We've got a cubic, so we're looking for an S shape, and we see that negative in front of the x cubed, and so we know this negative tells me left hand or the left side, either way here, is up, is what we're expecting. Right side down. And so first things first, we'll check out the intercepts here. X-intercept when y equals 0 again, don't forget about that. 0 equals negative x cubed plus 1. And so negative 1 equals negative x cubed, and x equals 1, or x equal 1 when we take the cube root there of both sides. And so we've got an x-intercept at 1, 0. Let's check out the y-intercept here. Remember, that happens when x is 0. And so let's see, y equals negative 0 cubed plus 1, y equals 1. So we've got the point 0, 1, so we can plot those 1, 0 and 0, 1. Oh, let's see what we get if we let x equal negative 1. Y equals the opposite of negative 1 cubed plus 1. We're looking at the opposite of negative 1 plus 1, which is 2, so we've got the point negative 1, 2. We can see if x is negative 2. We're going to be off of our grid here. Maybe we'll check out when x is 2. So we've got y equal the opposite of 2 cubed plus 1. Well, this is negative 8 plus 1, or negative 7, so 2. 1, 2, 3, 4, 5, 6, and there's 7. So our graph looks something like this. Now we will test for symmetry here. And let's start out, I guess, up here. Symmetry. With respect to the, let's go with the x-axis first. So we're going to replace y with negative y, and just looking at it, symmetric with respect to the x-axis? No, not at all, because we don't have anything up here. We can check that though algebraically. It'd be good practice for us. Negative y equals the opposite of x cubed plus 1, so y equals x cubed minus 1. No symmetry there with respect to the x-axis. We'll check out the y-axis here with respect to the y-axis. Well, we're going to replace draw ourselves a little line here. We'll replace x with negative x, and so let's see, y equals the opposite of negative x cubed plus 1. We're looking at negative x cubed, that makes it positive x cubed plus 1, so we're not symmetric with respect to the y-axis. And now let's check out the origin with respect to the origin. Replace x with negative x, y with negative y, and so let's see, negative y equals the opposite of negative x cubed plus 1. Negative y equals the opposite of negative x cubed plus 1. And so let's see here, negative y equals x cubed plus 1. And then y equals negative x cubed minus 1. So we do not have symmetry with respect to the origin either. And we would expect that. Moving ahead here, we will take a look at one more example. Example 3 here, y equal the square root of negative x. Once again, we're going to look at the intercepts here first, and so let's go for the x-intercept. When y equals 0, we get 0 equal the square root of negative x. We square both sides. 0 equals negative x, and of course the opposite of x equals 0 means that x equals 0. So there's our x and our y-intercept. We'll make note of that. We'll write that as a point. And then we might make note up here that our domain is actually going to be the set of all non-positive numbers here, because if x is a positive number, we're taking the square root of a negative number, and we have to be graphing over the reals here. We have not learned yet how to graph over the imaginary numbers, so our domain here is a set of numbers from negative infinity to and including 0. And if we throw a few points in here, y equal the square root of the opposite of negative 1, and of course we're looking at 1. If we let x equal negative 4, if we let x equal negative 4, we're looking at y equal the square root of the opposite of negative 4. Well, this is the square root of 2. Alright, so we got a little bit of an idea of what this guy should look like. Now, let's check this out here and see if we have any symmetry. Of course, we would not expect any, because if we had symmetry, we would expect this point over here. If we were symmetric with respect to the y-axis, we would expect this point down here. If we were symmetric with respect to the x-axis, just for thoroughness here and to demonstrate how this might be handled algebraically, we'll test for symmetry first with respect to the x-axis. And so the x-axis, let y equal negative y. And so we've got negative y equal the square root of negative x. Y equals the opposite of the square root of negative x, so not symmetric there. With respect to the x, no surprise, let's check out the y-axis. We're going to let x equal negative x, and so we've got y equal the square root of the opposite of negative x, which is the square root of x, so no on the y-axis. And then of course the origin, we need to let y equal negative y and x equal negative x. And so let's see, negative y equals the square root of the opposite of negative x. Negative y equals the square root of x. Y equal the opposite of the square root of x, and as we expected, that does not work either. So no on the x-axis, the y-axis, and the origin. And now, if you would, for class discussion, please work 4 and 14, have those ready to go up on the board, and then you can see the homework here. Of clearly we've got a typo here, 1, 6, 7, 12, 13, 19, 21, and 22. And we can cross those out. Moving along here, some notation that gets used a lot in calculus, and so we're going to take a little bit of time here and study it in some of its most basic forms. When we see something like x arrow 1 superscript negative, this means as x approaches one from the left. As x approaches 1 from the left. If we have something like this, x arrow 3/2 with a plus sign up here, this means as x approaches 3/2 from the right. And then f of x arrow means f of x, which remember that equals y, approaches, and then we're trying to figure that out. So let's take a look here. As x approaches 1 from the left. So here we go. We are writing this graph along, going from the left, and we're getting very close here. Getting very close. We have arrived at x equal 1. And as x approaches 1 from the left, my y value is approaching 1/4. Now, some of you are probably thinking, well, wait a minute, what's going on as x approaches 1 from the right? And let's just take a look at that. And as we approach 1 from the right, you'll notice that we also have a y value that approaches 1. Same thing is true with 3/2. And let me switch colors on that so we can see it maybe. So we're approaching 3/2 from the right, coming in here, doing this in red. We approach 3/2 from the right. And as we approach 3/2 from the right, we approach y approaches 27/32. It is the case here that as x approaches 3/2 from the left, f approaches 27/32 as well. We'll see cases when we get into calculus, and maybe even this semester yet, where as we approach from the right and approach from the left, we'll get different y values, but that's not the case here. Take a look what happens as x gets really big. And folks, x approaches infinity. We're riding way out here. My x's are getting big. So are my f of x's. And so f of x approaches infinity. Same thing out here as x gets really small. Here's x approaching negative infinity. Notice that y is also going to negative infinity. Now, it's not always the case that as x gets big and goes to positive infinity, y does, but it is the case here. And so with that in mind, please take a look at 23 and 24 in your homework. We're not going to have any class discussion questions on those, although certainly if you have questions about 23 and 24, please make those known in class. Well, here we are, figure 5. This should look vaguely familiar, probably a little bit better than what I had in our notes yesterday, as we've got a perfect circle here. We've got a center at HK and some random point P on the circumference of this circle that we are describing with the ordered pair XY. And we spoke briefly yesterday about the standard equation for a circle. This is one that we should have down, and of course if we square both sides, we have this right here, our standard equation of a circle without the square root. And so you'll notice that our H and K serve as a center. And so looking at example 5 here, which is problem number 30, let me rewrite this as x minus h quantity squared plus y minus k quantity squared equals r squared. And so this is x minus 0 quantity squared plus y minus 2 quantity squared. This equals 5 squared. And so you'll notice we've got a center at, not real sure what word that's supposed to be. Let's erase him. We've got a center at 0, 2. Please notice that here it's x minus h, so it's x minus 0, y minus k, so it's y minus 2. We've got a center at 0, 2, and we've got a radius that's equal to 5. And so we know we have a circle. Let's see if I can sketch this somewhat carefully. 0, 2. And for our radius, I need to go 1, 2, 3, 4, 5 units this way. 1, 2, 3, 4, 5 units this way. 1, 2, 3, 4, 5 units this way. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5 units this way. And if I connect my dots, here's my circle. Clearly that is not the best circle in the world. As long as you've got your points that are clearly 5 units away, and I can see that, I will be okay with your circle if it looks like mine. Moving ahead here, we'll look at our 6th example, and you notice here that we've got numbers in front of the x's. Well, that's okay. We can divide everywhere by 9, and so my equation here becomes x squared plus y squared equals 4/9. And remember, this is x minus 0 now, quantity squared, plus y minus 0. You got to be thinking, okay, x minus what, y minus what? And this equals 2/3 quantity squared. And so I've got a center at the origin and a radius of 2/3, and we get ready to draw this. Here's 1, 1, out 1 unit, out 1 unit, 2/3, 2/3, 2/3, and 2/3. Well, we're doing pretty well till that little squibble came in there. Let's see if we can fix that. There we go. Somewhat close anyway. And like I say, I would be okay if yours is a little rocky there. Alright, if you've checked your book out, you might notice that this problem did not come off quite the way it was printed in the book. I apologize for that. If we look at what we have here, x equal the opposite of the square root of 25 minus y squared. If we were to square both sides here, we'd get x squared equal 25 minus y squared, and then we'd have x squared plus y squared equal 25. Now, this is not what we were asked to graph. Okay, this clearly would be a circle with a center at the origin and a radius of 5. Center at the origin, radius of 5. Now that's not far from what we've got. Okay, that's not far from what we've got. But you notice this negative, and you guys have had enough experience. You guys have had enough experience before, I think, when we have x equal a negative square root. You guys know that that is going to apologize. That is going to be a left half of a semicircle. So we've got the center at the origin here and a radius of 5, Okay. And so you say, well, how can I tell that? Well, you can try out some different values of y. If y equals 1, for instance, we're going to have the opposite of the square root of 25 minus 1 squared, which is going to be the opposite of the square root of 24. You'll also notice if y equal negative 1, we've got the opposite of the square root of 25 minus negative 1 squared, and this is still going to be the opposite of the square root of 24. And so we can see when we get ready to graph these, y equal 1, we've got x equal the square root of negative 24, or wherever that is here, and then when y equals negative 1, we've got x equal the opposite of the square root of 24 as well. So we've got the left half of a semicircle there. And now you guys can take a look at 26 and 34. I expect some good class discussion questions here on these two, especially as we deal with circles and semicircles. And then there are 5 problems for you to work for homework that will turn in a couple of days. Now we're going the other direction. Example 8, which is problem 40 in your study guide, asks us to find the equation of the circle satisfying the stated conditions. Well, let's see. We've got x minus, what's h? It's 3/4 quantity squared, plus y minus negative 2/3 quantity squared. This equals 3 root 2 quantity squared. Alright, and we can clean this up just a bit. X minus 3/4 quantity squared plus y plus 2/3 quantity squared equals 3 squared is 9. Root 2 squared is 2. This equals 18. And so if there are questions on that, as always, bring them along to the class discussion. It'll be fun to look at them, as it always is. Let's look at example 9 here. Now example 9 is similar to 45 through 48. And I've given you a couple of those to work. If you have questions, certainly you know that you can ask about them. Let's look at the graph here so that we can understand kind of what's going on. We've got a center at negative 5, 1. And given that, let me move this graph over here just a minute. Apologize for the delay. So we've got our graph here, 2, 3, 4, 5, negative 5, negative 1. And this circle is going to be tangent to the line x equal 4. 1, 2, 3, 4. Now, remember what the line x equal 4 is going to look like. Okay, it's going to be a vertical line. Every point on that line is going to have an x-coordinate of 4. And we know that if it's tangent, that circle is going to lie on that line straight across from the radius. And so if we're straight across from the radius, here's negative 1, negative 5, negative 1, that's the point we're on. And so folks, we can figure out, without doing a lot of work, this is the point for negative 1. If we needed to figure out our distance between these two, which we do, we could go a few ways. We could say, well, we're 5 this way, 4 this way, so my radius is 9. I could say 4 minus a negative 5, that distance is 9. Any way we wanted to look at it there, the radius of this circle is 9. We know if we've got x minus h quantity squared plus y minus k quantity squared equals r squared, we're looking at x minus a negative 5 quantity squared plus y minus negative 1 quantity squared equals 9 squared. our equation, x plus 5 quantity squared plus y plus 1 quantity squared equals 81. And there we go. So for discussion, please work 39 and 42, have those ready to go. And then for homework, you can see the list of problems that we want to take a look at there. Now, you may have observed that in order to determine a center and a radius, it is easiest if the equation is in this standard form. And the center will be at HK with a radius of R. Well, what happens if we get something now like we have in problem 52 in our set, where we don't have that situation? In fact, we've got x squared minus 10x. Oh my, what's that 10x doing in there? And then I've got a y squared, and then, well, I think we've figured out that we want the constant on a side by itself, so I'm going to move that negative 18 over, or I'm going to move the 18 over, making it negative 18. Now, I've done all of this so that I can complete the square in both the x and the y. And you're thinking, oh my goodness, complete the square. We did that somewhere in my past. How does that work? Well, you might remember that we like to have a 1 in front of our squared term. We've got that here. We are going to take 1/2 of my b value, in this case the value in front of, and in all cases, the value in front of my linear term. I'm going to square that, and I'm going to add that to both sides. So 1/2 of negative 10, we're going to square that and add that to both sides. You'll notice I don't have a linear term in y, so I'm just going to leave that as y squared. The left now looks like x squared minus 10x plus half of negative 10 is negative 5. Square that, we get 25 plus y squared, and this equals negative 18 plus 25. So we're looking at x minus 5 quantity squared plus y squared equal 7. Well, how about that? Now we've got back our x minus h quantity squared plus y minus 0 quantity squared equals r squared form. And so we know we've got a center at 5, 0, with a radius of the square root of 7. Let's look at one more example here. This one, oh my goodness, looks a little messier. Notice we've got a 4 in front of the x squareds and the y squareds here. I'm going to go through and divide every term by 4, as most of these examples are. This one's cooked up so that when we divide by 4, we get some relatively nice numbers. X squared, now guys, I'm going to get the x's together here. X squared plus 16x, leave a space. That same completing the square formula or concept that we used in the last problem will be handy here again. So I'm going to leave a space. Plus y squared plus 6y. And I'm going to move this negative 31. I'm going to move the 31 fourths over, making it negative. All right. So now 1/2 of 16. We're going to square that and add that to both sides. 1/2 of 6. We're going to square that and add that to both sides. So we've got x squared plus 16x. Half of 16 is 8. Square it, that's 64. Plus y squared plus 6y. Half of 6 is 3. Square that, that's 9. Negative 31 fourths plus, there's the 64, there's the 9. So now we can factor as the perfect squares that we have here. We'll notice that we have x plus 4, x plus 8, quantity squared here, plus y plus 3, quantity squared here. My goodness. Let's see what we're getting over here. And mercy me, I'm taking a look at something here as I work. 16 over 4 is not still 16. So I apologize. We need to make a correction here. And so let's just back this up here just a little bit. Fix a couple things. So let's try this again. My apologies here. Half of 16 divided by 4 is 4, so we need a plus 4x there. And now 1/2 of 4, square that. Okay, so we are looking at, what are we looking at here? Well, we're looking at x squared plus 4x, and then 1/2 of 4 squared is going to be, 1/2 of 4 is 2, we're going to square that, so we'll have 4. Okay, and we can add that to both sides here. Let's go back here. Alrighty. And so plus 4, and then we've got our plus y squared plus 6y plus 9. So this is going to be x plus 2, quantity squared, and then over here we've got a 4. Alright, so this is a little nicer to work with now, isn't it? Negative 31 fourths plus 16 fourths plus 36 fourths, getting a common denominator here. So we've got negative 31 plus 16 gives me a negative 15. 36 plus negative 15 gives me a 21 over 4. And so I've got x plus 2 quantity squared plus y plus 3 quantity squared. This equals 21 over 4. I've got a center, a negative 2, negative 3, and a radius of, this is the square root of 21 over 4, which is the square root of 21 over 2. And so you guys can try out 50 and 56 for class discussion. And then for homework, please work 49, 52, 53, 54, 55, 57, and 58.